The presentation I have for you today is attacking Gotenna networks. Quick disclaimer, you should definitely try to not violate federal laws, FCC regulations, applicable laws in your state and country, all that good stuff. Anything I say is my personal opinion and not the opinion of my employer, so don't blame them. A little bit of background. I've been doing this professionally for 18 years, doing vulnerability research, attacking various wireless systems, medical devices, life-critical devices, and infrastructure. For those of you not familiar with Gotenna mesh, this is what we're talking about. We're not talking about the first generation Gotennas, we're talking about the second generation Gotenna meshes. This is what's inside that lovely little plastic case. For those of you in the wireless hacking village, something should jump right at you. First of all, is that really amazing antenna that you could swap out, which actually doesn't exist because it's a regulated device. It does not require licensing, so it's really limited by its power output. You're not supposed to be able to add on an auxiliary antenna. Of course, some folks have been modifying them. Second thing you should notice is that amazing tiny little battery, which supposedly lasts 24 hours, but from the testing you've done here at Defcon, you're getting about 3.5 hours, especially with the people that have been spamming the network. This is built as a device that you could use when networks go down, when everything else fails. So something you should notice is the waterproof seal on this case, which also doesn't exist. It's basically ultrasonic welded together, which means if there's pouring rain and flooding, again, these devices don't seem to survive very well. So why are we doing a talk about attacking something that's supposed to be the backup network when everything fails? Well, first of all, the only way to see if something is really has any business being an emergency communication device is to see whether or not their claims are true. And they're touted as emergency infrastructure. They received quite a bit of FEMA funding. They're being deployed at some of the large ski resorts to help people find their families in the mountain, but also to be used during emergency communications. New York City actually is giving away quite a few of these to businesses that were previously impacted by Sandy. So again, a large metropolitan area, 8+ million people who are going to be relying on it as critical infrastructure when there is no cell phone service. So Gotenna has had an opportunity to become emergency infrastructure in Puerto Rico. We have not had a lot of good data coming back about how well it's working. It's kind of been scattered because, well, right now things are still mostly down. From what I've been able to find online has not been very encouraging. We're going to go through some of those things. Quick specs, interesting things of note. You'll see the amazing output of 1 watt. Not exactly what you want to see in emergency infrastructure. ISM radio band, 900 megahertz roughly ISM, covers both region 1 and 2. It can work with cellular interlink if you pay for the premium subscription. We're going to get into that. Again, if this is emergency infrastructure and the cellular goes down, then so does your cellular interlink. So again, not very helpful. Compare that with a typical handheld walkie-talkie that covers VHF, UHF bands, somewhere in 5 watt range. In some cases, a lot more if you buy from certain shady Chinese manufacturers. You're able to have APRS, which is an automatic position reporting system. Makes the radio quite a bit more expensive, but again, it gives you actual digital radio that you can connect to a computer, you can send messages, you can send positioning data. You actually have a GPS that's built into the radio. It's an open standard, so you're not locked into a dinky little plastic device. It's an open standard, so you have interoperability. You can use multiple manufacturers, multiple different components that you can kludge together, even just doing plain radios and open source software on the Raspberry Pi. And of course, again, if you buy radios from certain shady manufacturers, you can do out-of-band operations covering MERS bands, ISM bands, in some cases even police frequencies, which you should definitely not transmit on, but receiving is obviously fine, depending where you are. Cost of entry, this morning, the Gotenna mesh was $179. Baofeng radios were still $22 on Amazon Prime delivered to your door.
$179 for two.
Yeah, for a pair.
Okay, sorry, yes. So it's $179 for 2 Gotennas, correct. But you need 2 of them to work. If I have 1 Gotenna, then I can't call this gentleman because he may not have a Gotenna, so.
Same thing with the radio, though. Same thing with the radio, the Baofeng.
Correct, yes. You have a wide community of ham radio users as opposed to people who just bought into this closed ecosystem. And of course, all the police officers who are not linked to the computer at the moment. Looking at Kenwood radios, you have an actual digital modem, again, built-in GPS, something that you could use without a cell phone being connected. Basic operations. First, you need to install the Gotenna application on the phone, which becomes rather difficult if the internet is down. So even if you were to airdrop Gotenna somewhere, the instructions start out with fully charge your Gotenna. Well, power's down. Then you download the application from where internet is down. You connect your phone to the Gotenna, and you turn on the Gotenna essentially, and then you could connect with other users, and your messages can travel hop to hop. For the reason I put down is X number of hops. Up until a few weeks ago, it was 3 hops. Last update, they pushed it out to 6 hops. Again, because of propagation issues, because you're only getting a few city blocks if you're really lucky with these radios. Looking at the FEMA website, this is what they demand from emergency infrastructure. It needs to be resilient, meaning it'll stay up even if there's flooding, if there's monsoon rains, earthquakes. Needs to be robust, needs to be secure, reliable, and that last one, open standard. I haven't seen any other radios that work with Gotenna mesh, so again, that avails on that point alone before we even examine the secure portion a little bit deeper. Encryption. Encryption is handled in a cell phone application, not on a device. That means it opens up the iPhone and Android devices to attacks. There's been 2 major updates to the Gotenna application, so we had to scramble to do a kind of a source code review while we were here at the conference. So we're going to be publishing the updates slides with actual issues that we found in there. What I can tell you is that we have initialization vector issues in the open source script that they're using. There's key storage issues. Once the key is actually generated, it's stored in a way that's essentially accessible to many other applications on the device. So if you have a malicious application, or if you don't fully trust the government in an area where you're running the application, the key could be extracted and moved to another device. And we have implementation issues. The algorithms that they're using are sound and peer-reviewed. However, their implementation is flawed. One of the big features they tout for connectivity, again, is Gotenna plus SMS relay. So if somebody's paying for a premium subscription, they're using somebody else's device for backhaul and using cellular connectivity, which is really great if you're in the middle of a city and everything's working fine. Not so useful if cell phone towers are down. When somebody's doing a default install, the GID, which is the global unique identifier, by default is set to be your cell phone number. Again, not really great for anonymity. It is possible to set the GID manually, but it's not very straightforward. You essentially have to know that you want to do this and go back and do it. So if you're in a large network, such as here at Defcon, we've been harvesting quite a few phone numbers, so even the audience here has been using phone numbers. We haven't called up those people to verify if they're indeed the Gotenna users, but in large cities they typically are. Public shouts, again, the phone numbers go out in clear text, and emergency broadcasts include the GID as well as somebody's GPS location or somebody's last known GPS location. So your cell phone application is leaking data. There's been a really fun application released in the iOS store, which is the Mesh Developer Toolkit. So we've been able to do open source recon and developers who are working on the Gotenna mesh devices and essentially locating them physically on the map and their Gotennas. So we have a nice comprehensive map of where they are located in New York City, where they go out to lunch with their phones, still running the application.
So that's San Francisco.
You're going to see if you want to release the full list or not. So we took the default screenshots from California, but I think we're going to release the New York map. You mentioned the GID briefly. By default, it's the phone number. It's totally non-alphanumeric. It is user configurable, so that decreases the attack surface if you want to iterate through all the cell phone numbers. The Gotenna mesh application, the official one, does limit how many direct messages you can send, but since it's an open SDK, you can go out there and be an asshole and grab 500 API keys and just start spamming the whole network for hours and hours, and there's absolutely nothing that anybody can do to stop you. And of course, there's no authentication, so it's not like you can kick me off the network. One of the most fun GID attacks to be implemented, by the way, if you're in this room, you may have noticed that your Gotenna connectivity has dropped significantly, is the GID attack. The way it works is it bases the hop count on the GID of the device, the global unique identifier. However, you can pair multiple antennas to have the same GID. So, for example, I have a device with GID of 1, 2, 3, 4, 5, 6, 7, 8, 9, and I'm a good citizen, I'm helping you broadcast on a network. But wait, this device has the same GID, and this device, and possibly his device. Now all of a sudden you have messages essentially round robin in the same network. Their packet count is dropping, so I receive a message, and the repeat hop count is 6. And if we broadcast, it drops the packet count to 5. Then this radio gets in, says, it repeats with the same GID, drops the packet count to 4. This radio receives it, drops the packet count to 3. So now the distance your message can propagate has been dropped to essentially half of what it would have been with the distance of what's in my cargo pocket. Again, not resilient infrastructure. And just to reemphasize, emergency situations, it could be a nation-state level attack. It could be a bunch of Saudi citizens that got on a plane and intentionally caused a grid-down situation. So if you can implement an attack that drops your emergency infrastructure for the cost of under $200, that is not robust. If you want to play with this attack, what you need to do is you need to set up one Gotenna with your friend's GID. So essentially find out somebody who's using Gotenna, set up their phone number, pair the Gotenna, turn off the Gotenna you've been using, and pair a new Gotenna. So essentially you're telling the app that you dropped off the old Gotenna without deleting the GID from the actual radio. So this lets you bypass the controls within the application that prevents the GID attack. If there were duplicates in the application, what you do is you stop by and pick up a few burner phones, $20, $30 phones, and you set up the application with the custom GID being exactly the same. Another really funny thing is if you program your friend's GID, because these devices are meant to work offline, it doesn't do proper certificate validation. So if you know that your friend is supposed to do a secret rendezvous with somebody else and you set up their GID and you go there in their place, you will receive the direct messages that are meant for them that are supposed to be encrypted, and your device will successfully decrypt them because, as I mentioned, there's an initialization vector issue with how Gotenna does encryption.